So here we are, 1.1 B as in boy, and again, this is college algebra, and we are getting ready for the distance formula. And you remember, we've got Pythagorean, which is a squared plus b squared equals c squared, where a and b are both legs to a triangle, and c is always a hypotenuse to the triangle. And we're going to use what is called the distance formula, which is a morphed version of the Pythagorean theorem. You can read on the bottom of page 64 how they come about with the formula, but the formula actually is the distance of anything is always the square root of an x variable minus another x squared plus the y minus another y squared. Alright, so I'll explain what that means here as we go. So let's say that we have example 6, negative 2, 2, and we also have another point 3, negative 6. And we want to find out how far it is between those 2 points. If we were to graph it, we would have a point negative 2, 2, and a 3, negative 6. And we want to know how far it is between those 2 points. So actually what we've got here is a triangle, and we use Pythagorean. So we have this as my y, and this is my x, in order to find this distance here. So that's where the Pythagorean comes from. But just using this formula here, I can write that as d equals, alright, one of the x's. Doesn't matter which one. We can use this one or we can use this one. I don't care. Nobody cares. So just pick one. So let's use the first one minus the other one. And it doesn't matter because it won't change the value of the answer. Alright, the y here. It does matter which one you use because you used the negative 2 for x2. You have to use the one that goes with negative 2, this one here, for y2. So if you use this for an x2, this has to be your y2. So here we go. So my y2 is 2 minus, don't forget, okay? So I get d equals negative 2 minus 3 is negative 5 squared is a positive 25. And this is 2 plus 6 is 8. 8 times 8 is 64. So d equals the square root of 89, or a number similar to 9.4. Okay? Alright, let's look at the b portion of this problem. And see if I can answer any questions in the video that might be happening. So we've got, again, 2 points. And I've got my d equals square root of x2 minus x1 squared plus Okay, so I've got my distance formula. So distance equals the square root of negative 1 minus, whoops, I'm just going to put negative 1 squared plus negative 5 minus 2, the quantity squared. So d equals 0 plus, this is negative 7. And we're under a radical, so my d equals a 49 under a radical, so my d equals 7. Alright, so the distance between these 2 points is 7. Alright, so let's look at example number 7. Got a circle here. Okay, there's my circle. Let's see, what is this asking for? It says the point negative 2, 5 is on the circle, and 3, negative 1 is its center. So 3, negative 1. So that point is 3, negative 1, which means that we had to go over 3 and down 1, right, to get there. So 1, 2, 3, and down 1. And that's where my center is, right there. It also says that point negative 2, 5 is on this circle as well. So let's just say, well, somewhere over here, negative 2, 5. Okay. find the length of the radius of the circle. So what they're asking us to do is find out how long this is, what the radius is. Now it doesn't matter even if you graph this correctly because they gave you your 2 points. Okay, so all you're doing is putting it in here as a distance formula. So D equals, again, 25 plus 636. So that gives me the square root of 61 is how long that radius is, or a number similar to 7.8, and that's how long that radius is. Okay, so that's example number 7. All right, we're going to jump to this next section that has to do with midpoints of a segment. Sometimes you want to know where the halfway point is. All right, the halfway point is, here's the formula. Halfway point is always the first x plus the second x divided by 2. The y value is the first y plus the second y divided by 2. That's it, if you want to know what half of it is. So, for example, if I have a graph here, and I have a couple points, say I have one there, and I have one there. And let's say this is -4, -2, and this is 0.25. And I'm not interested in how long it is, I'm interested in where is the halfway point. Okay, so I'm going to take my x values and add them together. -4 plus 2 and divide it by 2. And then I'm going to take my y values and add them together. -2 plus 5 and divide that by 2. Always divide by 2. So that gives me -2 over 2 and 3 over 2. So there's my points. -1, 3 halves. That's the halfway point. So I go over -1, up 1.5, and that point right there is my halfway point. Okay, key thing. That's not the distance between here and here. It's the point that lies halfway between the distance between there and there. Okay, it just tells me where the point is at the halfway mark. Okay, very important to remember there. All right, let's look at example 9, because one of the things that's important when you're dealing with circles is the halfway point of a diameter would be the center of a circle. So we've got the diameter of a circle connects 2 points, 2, -3, and 6, 4 on the circle, meaning I have a 2, -3 point here, and I have a 0.64 there, and there's a diameter that connects those two. I want to know where the circle center is. What are the coordinates of that circle center? Again, not how long the diameter is, but where is the center of the circle? If I were to graph it, would I be able to say it's at 0.32? Okay, that's what I'm doing here. So I'm taking my x and adding, divided by 2, and my y and adding, and divided by 2. So I have 4 and 1/2. Those are my 2 points. So if I were to graph 4 1/2, it would be the center of that circle there. Which brings us into the next section here that has to do with circles. All right, a circle is the set of all points in a plane. Okay, I've got a circle here. All points on a plane, all these points that are equal distance from the center, and we call the center of a circle HK. HK is basically XY, but when we're talking the center of a circle, we call it HK, just so you know we're talking the center of the circle, not just coordinates. So we use the word XY. So, what we have is our distance formula. Distance equals, let's write it again, x2 minus x1, the quantity squared, plus y2 minus y1, quantity squared. Notice that distance and radius have some things in common. The radius is going to be, using this formula, x minus the distance from the center, the x part of the distance, and the y part of the distance. So there's the formula for finding the radius of a circle. Which brings us to what's called the equation of a circle, using HK as the center point. The equation of a circle looks like this. Okay, now an equation of a line looks like this. Okay, you've learned that. That's the equation of a line. This is the equation of a circle. So if you have an equation that looks like this, is in this kind of a form, then you know that you're talking about a circle. All right, so let's see if we can move some of this junk up here. Leave the equation of a circle there. All right, so example 10 says, find an equation of the circle having radius 5 and center 3, -7. We're going to look at this equation here and fill it in. Okay, so let's get another color here. Let's do kind of a pukey yellow. All right, so what is my center? 3, -7. So 3 goes in here for H. Okay, plus Y. And what do we have? Oh, we have a -7. I'm going to put, and this whole thing is squared. And that equals what? R squared equals the radius squared. Do we know what the radius is? 5. Okay. So there we have x minus 3, quantity squared. I'm just going to clean it up a little bit. Make that plus 7 equals 25. And there's the equation of a circle that has a radius of 5 and a center of 3, -7. Okay, let's keep going here, and I think I'm gonna go ahead and let's see. I guess I just have a little bit more, so let's continue. I think I have time, so I'm going to turn this off. All right, so there's example 11, and it's saying to graph the circle. Okay, so what do I know about the circle? I know the radius is not 16 because remember the formula had it equal to r squared, so the radius is the square root of 16. Okay, because the radius is 4 squared, right? And so that means that my radius is 4. What else do I know? Let's go ahead and write the equation. We have to write it this way. So instead of x plus 5, I'm going to write this as 4 squared equals x minus a -5, because I have to change this plus to the negative that we have here. So the only way I do that is make it minus, like this, a -5. So it has to be in that format. My y is already, okay, it's already a -2, so I don't have to change that to anything. Okay, so the center of my circle is going to be whatever number this is, whatever number this is. So remember, if this is a plus, you've got to change it to a minus, a negative. So my center is -5, -2, or I'm sorry, +2. Okay, and my radius is 4. Now, why is this a +2? All right, what does it say? My center is HK. We ignore the minus here, we ignore the minus here. So H is, ignoring this minus, -5. K is, ignoring this minus, a +2. Okay, this is the tricky part. This is x plus 5, but it has to be written as x minus something. So the only way I can write it is x minus a -5, which is the same thing as x plus 5. This has to be a negative. So whatever is to the right of the negative is your coordinate, your x coordinate. Whatever's to the right of this negative, a 2, goes there. All right, so that is it for section 1.1.